How are you doing today? My name is Harmon.
I'm Joshua.
And I'm Alex.
And today we'll be presenting our Java program, Jumpy Christmas, to you. Right now you're looking at the main menu of the game. Here you can see the play, the instructions, the credits, and the quit. If we were to play the game, the main idea is to make the character stay alive while jumping over obstacles. As you can see already, the character did hit an obstacle, so what comes up is your score, and you can either press the main menu or retry. If you press the menu, we'll be back to the main menu, and if you press the settings in the left corner of the screen, you can either mute the volume, you can change the speed from slow, medium, and high, and then you can also go back. So there's other things on the game that you can do. Is you can see the instructions, which show you how to play the game, the credits of who made the game, and the quit. So if you were to play the game again, you can also pause the game. So if you're to retry, you can pause the game, and from pausing you can go back to the main menu, continue, or retry, and also mute the volume.
Within the game, all the objects are defined based off the default abstract class game objects. Objects that inherit this class will have their location X and their location Y defined, then their name defined, which is based off the object type enum over here, and then their horizontal speed and then their vertical speed defined, and lastly the Boolean variable that tells if there needs to be an other object of the same type that needs to be created within the game. The methods that objects inherit from this class are update object, which constantly updates the movement of the object, and also render object, which constantly redraws the object based off the updates. There's also getter and setter methods for this abstract class, which returns back the values of the attributes above or changes their values. Also, all of the objects within this game are controlled based off the object handler and the menu object handler. Menu object handler controls all the objects within the menu screen, while object handler controls all the objects within the game itself. In these handlers, they all contain a linked list, which stores all of the objects within that state. And every time, and when the computer runs the code, it will constantly goes through the whole list and then updates and renders any object that are inside the list based off using the game loop that's defined in the game's main page. Also, objects can be added or removed from the linked list using the add object or remove object methods, which needs to search the object using an index. So within this game, there are several types of objects that are included. The first type is the player class, where the player's movements is controlled based off the user's key inputs that they put in. Also, by default, when the character is walking, they will constantly change from the character standing sprite to the character walking sprite for every 250 milliseconds. Also, whenever the player presses the jump button, it will first change into the progression jump sprite, then whenever they're above ground, it changes to the character jump up sprite, and then when the player is falling towards the ground, it changes to the character jump down sprite. Next two objects are spawner generator classes. The first type is snow.java, where by default there are 200 snowflakes that are created at the top of the screen. However, once these snowflakes touches the border of the screen, it removes the object, and then it adds back the object back at the top of the screen. And then the second type of generator or spawner class is based off is from the obstacle.java. So for this class, first only one object is created. However, it will select a randomly selected time delay between each before recreating a copy of itself, and then the copy will repeat the process and then recreate another copy, and then so on and so forth. So in theory, the object should infinitely recreate itself within the game. So lastly, there's the path class, which according to the game is represented by the shadowy path of the character or the objects whenever they move. So what this class does is that at first it creates a stationary copy of the object at a certain position, and then as time goes on, its transparency slowly decreases until it reaches the minimum transparency, where it then removes the object.
This table is the indication of has a relationship as well as the inheritance. So the blue lines represents the relationships, as well as the red lines represent the has a relationship. So let's take a closer look at the code. So, okay, in this gamestats.java, the public class obstacle extends to game objects. So now if we go back and take a closer look, the game object is related to the obstacle. So in the sense that the game object is inherited by the obstacle. And now if you look over here, the ground, the glow Java, menu snow, as well as menu cursor snow are all inherited by game object, while states are related to gameover.java, instructionscreen.java. So these are, in a sense, calling on each other within the code.